Now, in this problem, what we've got is our curve, which is y is equal to x cubed. We're rotating around the line y is equal to x minus 2. X is equal to 2, sorry. So, again, our thickness is going to be delta y, because we're rotating around that curve, that line. We're also looking then that we have get our radius. So we've got distance of 2, and the point xy there would give us a distance of x there. So our radius would be 2 minus x. So hopefully we're able to see that it's 2 minus x there. So that leads us to the area. So radius is 2 minus x. Our area then would be pi times 2 minus x all squared. And with volume would be pi 2 minus x squared delta y. Now, because we need to get x in terms of y, we need to make sure that we realize that if y is equal to x cubed, then x must be equal to y to the power of 1/3, so the cube root of x. So that's where we get our function there, and we're able to put that into place between 0 and 8. So we can see that the y values went from 0, went up to 8 there, where the curve met the line x is equal to 2. That's where it starts to rotate about. So that's where we get our limits of integration, and we're able to expand it out, integrate, and then get our solution. In the last problem here, we've got the curve y is equal to 4ax, y squared is equal to 4x. So we've got a parabola on its side, and its lattice is rotated there around the line y x is equal to a. So this area, the lattice rectum, is rotated about that line x is equal to a. So looking at that, because it's rotating around a line that's x is equal to a number, we get delta y because of the thickness of y. Now our area of our circular disc that's formed, again, if that's a, and the distance from our point that we're going to choose is x, then we're going to have the radius of a minus x. So we're going from minus 2 to 2a, minus 2a to 2a, because that's where our area is rotating around. So our cross section starts to look like this. Radius was x minus a, and then the area is pi times x minus a minus x all squared, and pi a minus x all squared delta y. So if we start to go put that into our integration, we still have a problem because we're going from minus 2a to 2a, but we've got x in terms of y. We need x in terms of y because our integrating with respect to y. So manipulating this function, x is equal to y squared on 4a. So that's where we start to get that expression, a squared minus 2ax plus x squared is the expansion, and then we do our substitution from x to a before we can start to integrate. So we've also noticed we've gone from 0 to minus 2a to 2a to 2 lots of the pi. Let's just come out the front from 0 to 2a. So 2 lots of 0 to 2a was the same as minus 2a to 2a because it was had symmetry there. And that's cleaned up, integrated, and then substitution of a 0 and 2a in to get down to our function. So again, the integration, even though it's a little bit more complicated, is still not very hard at all. Just making sure we get that correct volume formula, and we're able to do our correct substitution, and making sure we get our correct limits of integration before. And then once we've got all that in place, the integration will usually just follow through pretty easily.